Today we are gonna do another question, which is taking force, length and time. So force, length and time as fundamental quantities. Find the dimensional formula of first of all, let's find it of density, and second of mass. In our SI system, we talked that mass, length and time and others were the fundamental units, but we considered force as a derived unit, whereas length and time were fundamental units. But in this case, the question is asking us to take force, length and time as fundamental units and find the dimensional formula of this. So let's try to find it. So let's first of all find it of the first case, which is density. So to solve this, so since force, length and time are supposed to be fundamental quantity, we have density, which is represented by rho, is directly proportional to F to the power A, L to the power B, T to the power C. In our previous videos, we did this individually and combined the equations, but I will write it directly since you know how to do it now, where A, B and C are constants that must be found. So removing the proportionality sign, let's add a constant, which is K, F to the power A, L to the power B, T to the power C, where A, B, C and K are dimensionless constant, where A and ABC must be found. So now let's write the dimension of everything here. So the dimension of density is mass upon volume, which will be ml minus 3. The dimension of force is ml t minus 2. So the question that you might have is, why are we using SI systems in here? It's to make our calculations easier. So now the time will be time, and finally the length will be of length. So here time, sorry, I wrote capital T, supposed to be small t, and where K, we already wrote that K is the dimensional constant. So now, since the relation is valid, we can say that the dimension of the left hand side must equal the dimension of right hand side. So dimension of rho is ml minus 3. The dimension of K is nothing. The dimension of F is mlt minus 2. The dimension of L is L. The dimension of T is T. So now ml minus 3 must equal to m to the power a, L to the power a plus b, T to the power minus 2a plus c. This follows the laws of indices. So now, on comparing the left hand and right hand side, since there is no t, it means t is raised to the power of 0. So on comparing, so basically what I'm saying is, equating the powers of common base, we get a is equals to 1. So a is equals to 1. A plus b is equals to minus 3, and finally minus 2a plus c gives us 0. So let's call this equation number 1, this equation number 2, and this equation number 3. So on solving we get, so a is 1, put the value of a over here, so 1 plus b is equals to minus 3, which gives us b is equals to minus 4, and finally c will keep here 1, so its c will be plus 2. Now we have ABC. So we have the way to represent it. So let's see what the question asks once more. It asks for the dimensional formula, not this formula. It asks for the dimensional formula. So to write the dimensional formula, we would have to write it like this. So rho will be k times f to the power 1, L to the power minus 4, t to the power 2. Hence, since the question asks for the dimensional formula, write the dimensional formula. Since k does not have a dimension, no need to write for that. And now just write f to the power 1, L to the power minus 1, t squared. So basically we replaced m with f, which gives us this result. So that's what the question was asking. Taking force, length and time as the fundamental units, find the dimension of density. So let's do the second question. The second question was to find mass. Find mass, which I'm going to represent by small m. So since force, length and time are supposed as fundamental quantities, we can say that mass is directly proportional to f to the power a, L to the power b and t to the power c, which means m must equal k f a L b t c, where a, b, c and k are dimensionless constant. So dimensionless constant. So now let's find the dimension of each of them individually. So we know that the dimension of mass is m in MK system or SI system. The dimension of force is mlt minus 2. The dimension of length is L and the dimension of t is t. So now, since the relation is physically valid, we can say the dimension of the left hand side must be equal to the dimension of right hand side. So we have this. So the dimension of m is m. The dimension of k is the 1 since it is dimensionless. The dimension of force is mlt minus 2 raised to the power of e. The dimension of L will be L. The dimension of t will be t. So now we can write it as m1 L0 t0. So let's see, there is only one m, which is raised to the power of a. L is raised to the power of a plus b. T is raised to the power of 2a plus c. So now we have to compare. So on comparing, we found that a must be equals to 1 and a plus b must be equal to 0 and minus 2a plus c also must be equal to 0. So on solving, a is 1, so put a equals to 1 over here, we will get b is equals to minus 1, and finally c, put 1 over here, we will get plus 2. So now we have the equation that we need actually, which is m equals to k times f to the power of a, which was 1, L to the power of b, which was minus 1, t to the power of c, which was 2. But the question has asked for the dimension of mass. Since the question has asked the dimension of mass, we have to write it like this. The dimension of mass will be, the dimension of k is nothing, so it's 1, so we can write f to the power 1, L to the power minus 1, t to the power squared, since k does not have a dimension. So this will be the answer that you require. So in the next video we are going to do another question. So till then, bye bye.